Okay, so this video is about section 3.7 in our textbooks, which really kind of gets into talking a little bit more about lines and parallel lines and perpendicular lines and those kind of things that we've been talking about geometrically, but they're just kind of putting them now on a coordinate plane, and so turning things into x's and y's. And so mostly some of the stuff that you saw last year in algebra, we're kind of hitting it again this year because those are really big concepts as you continue on to algebra next year. So I had you working individually, taking a look at that warm-up problem, and hopefully you had a chance to look at that in groups. I'm going to go ahead and talk about the answers a little bit. If you want to skip ahead, you can. And that's probably true of any point in this presentation. That you're welcome to skip ahead, but there are some things that I will kind of talk about a little bit. I know a lot of this is going to be review, but it might work in your best interest to listen to it. But certainly feel free to skip ahead if you feel like you're pretty comfortable with this stuff, so kind of pace it yourself. So we're just going to take a look at this one question. It's obviously this is all about looking at these. So looking at these guys, the slopes of these things, and so the steeper the slope, obviously, mathematically we talk about rise over run and those kinds of things, and so we can apply the same thing to sides of mountains. When we look at this, we start talking a little bit about the slope of these things. One of the things we talk about with respect to lines is just this idea of rise over run. And so, we can do this. This goes up 1,190 feet per every 3,300 feet. That does actually reduce to a fraction. If you put that in your calculator, this is what it's going to give you. 330. The slope of B here, same kind of idea. We put the rise over the run. And so if we simplify that, that's going to give us 50. And this one does reduce a little bit more than the other one. And we get C over here, 23 to 70. Oopsies. That's supposed to be, initially we just put those numbers in there. The rise over the run in this case. And so that reduces to 23 over 70. And initially we might look at this and say, well, how do we compare these things? Because, they're all different denominators, and it's kind of hard to compare fractions when they're big, clunky ones like this. So, the other thing you can do is just look at the decimal approximation of these. And so when you do that in your calculator, the easiest thing to do is just put a decimal point somewhere behind the actual calculation. There's also a button on your calculator that will convert the answer to a decimal. But when we do that, what the calculator would tell us is that this is 0.361. And of course, that's like 0.361 over 1. So what that's telling us is on average here, if I look at the slope of this mountain or the side of this hill, that for every 1 foot or meter or mile, whatever it is, that this thing is going to raise by 0.361 feet as well, whatever that unit is. So every one change in the x direction, there's also a vertical change of 0.361 in the positive direction, which means it's moving up from left to right. Okay, so this is 0.361. If I do the same thing for B, convert that to a decimal, I get 0.393, which is just a little bit steeper. And then if I convert C to a decimal, I get 0.329. And so you may have been able to figure this out just by looking at the picture, but a little bit more mathy. I think we want to sort of figure out which one is the steepest. So this one is definitely the least steep. C is definitely the least. So this is probably what we're going to call the easy one. And then our intermediate slope here is going to be this guy here. So this is intermediate. And this is going to be the difficult, the black diamond. Okay. And so we would probably want to put something to the effect in terms of an explanation, kind of articulating that a little bit, that the larger the value of the slope, the steeper the line, or in this case, I guess the side of the slope actually is going to be. Okay, so intermediate, difficult, and easy in order, ABC. Okay, so one of the things I'd like you to do is go on to this next slide, and I want to take a minute, if you could just pause it, and then go ahead and just list everything that you know about the slope of a line. So you've worked with slope quite a bit in Algebra 1, probably a little bit in Math 8 the year before that. So let's just talk a little bit about what you know about the slope of the line. So go ahead and hit pause, write a couple things down, and then we'll come back together in a couple of minutes here. Okay, so hopefully you had some of these things. Usually we think of slope as, the amount of rise over the run, and we talked about that with respect to the ski slopes earlier. That's also, if I have two coordinate points, you might remember the equation y2 minus y1 over x2 minus x1. Between two coordinate points, what's the difference of the y? Divide that by the difference of the x. Some things you may also remember are things like y equals mx plus b, where this value is the m, is usually a number, and that indicates the slope of a line. Other things to know is that a positive slope indicates that it rises from left to right. Okay, so if I look at this thing on a graph, it would look something like this. And if I have a negative slope, it does the opposite. It actually falls from left to right. So I have a line that maybe looks something like that. And might be more steep or less steep than that, but generally when you look at it from left to right, it goes that line goes down if it does have a negative slope. Okay, so two forms of linear equation. One we've kind of already talked about. The big guy here that usually most people remember is slope-intercept form, and slope-intercept form looks like this, where we have y equals mx plus b. And when that's the case, our slope is denoted by m, and the value of b is equivalent to the y-intercept, or where that graph is going to cross the y-axis. Okay, so that's our slope-intercept form of the equation with variables defined here. And of course, if we have an equation for a line, we would usually have x and y in the variable. We'd have those variables in the equation because the line itself actually shows us the relationship between x and y, and those values for m and b, the slope and the y-intercept, are just parameters or certain characteristics of the given line. We also have this other one called point slope. And much like the slope-intercept, notice that the way we get the name for that one is if we know the slope of the line and we know the y-intercept, we use the slope-intercept form. This one is very similar in that if we have a location or a specific point and we know the slope of the line, then we can actually find out what the equation is by using, probably a little bit easier to use this equation. So what we're going to do, we're actually going to derive this guy. We're going to start with our basic idea of the slope between 2 points. We're going to start with that generic definition, y2 minus y1 divided by x2 minus x1. Of course, that's equal to our slope. And what we're going to do with that, guys, we're just going to multiply both sides of this by x2 minus x1. So we're just going to do a little bit of algebraic manipulation here on both sides. All this does is really just clears the fraction. So what that's going to do for us is it's going to clear the fraction on the left-hand side. So over here I would have y2 minus y1, and over here I'm going to have the slope times x2 minus x1. Okay, so that's just rewriting the equation of the slope, just rewriting it, where it's not a fraction, I guess. Okay, so here's kind of the key point of this, no pun intended. But what we're going to do is we're going to let x, y, that coordinate point, be a point on the line. Okay, so xy is going to be a point on the line. And so all we're going to do with that is we're going to replace in this equation, we're going to place y2 and x2 with generic values x and y, so that we can, just like we have over here with the slope-intercept form, we have a generic x and y. Those will stay as part of the equation. We want that same thing to happen here for point-slope form. So when we make that substitution here, then essentially what that gives us is y, and substituting this guy for this, y minus y1 is equal to the slope. And again, instead of this, we're going to put x minus x1. All right, and that is our formula for point-slope form. Okay. And the basic idea here, again, is that given that we have the slope, right, this is the slope m, that's still the same slope of the equation that we use in the other one, and x1, y1, that's a point on the line. Okay, so if we're given the slope and we're given any point, then we can just kind of plug those things in here, and that would give us a relationship between x and y. And notice that x and y would be the only variables if we actually had numbers for the slope and a given point on the line. Okay, so we'll take a look at a couple examples of that in a minute. That one's probably a little less familiar to you than the slope-intercept form. All right, so go ahead and flip to the back then. And when we take a look at the back, I really just have like 5 different examples on the back. So what I might encourage you to do is to try one, and then so I'm just pretty much going to be walking through each of these and talking about them. But I think it would be helpful for you to try them first, and then go ahead and check your answers, and you can kind of skip ahead and whatnot. But if you're not getting the right answers, then make sure you go back and listen to the explanation. Part of this would allow you to kind of review this as it needs to be reviewed. And that's probably going to be a little bit different for each person. Some people might need to see a few more examples or kind of hear the explanation, and some people might not need that because they might remember it a little bit better from last year. So kind of, you be the best judge of that. So I'm just going to go ahead and start working on the questions. So I would encourage you to pause and at least do A, and then, then go ahead and listen to my explanation of that, or at least jump ahead to the answers, and then listen to my explanation if you need to. So I'm going to go ahead and start on A. So this is a pretty basic question here. You've probably been doing something like this for a while. What's the slope of a line that contains the points -2, -5, and -5, 4? And so, really, it doesn't really matter how you do this, but what I like to do, just to kind of organize it, is to call one of those points 1 and call one 2. And so, if I think about this formula, it's the difference of the y values divided by the difference of the x values, and I just kind of plug those in. So if this is my second point here, that's where my y2 and x2 are going to come from. So my y coordinate there is going to be 4, and I'm going to take the y1 from over here. Be careful of the signs on this. It is minus the value of y1, and then just make sure you do them in the same order. So if I took the y2 from this coordinate point here again, I need to make sure I do that the same order for the second, or for the horizontal, or the x coordinates as well. So it'd be -5 minus -2, which then when you simplify this will be 9 over -3, which of course reduces to -3 over 1, or just -3. Okay, so the slope of that first line is going to be -3, and again, you can write that as -3 over 1, or just -3. Okay, so take a look at B. What is the slope of a line that contains the points 3, -9, and -5, -9? So again, it's kind of the same deal. Go ahead and label those points. Just try to keep it organized. Your slope is going to be equal to y2 minus y1 over x2 minus x1. I'm going to take the y coordinate from the second point and subtract the y coordinate from the first point. And we do the same thing for the second one. -5 minus 3. Alright, so that's going to give us, this -9 plus 9 is going to give us 0 up here, and on the bottom, we're going to end up with -8. 0 divided by -8 is going to be 0. Having 0 on top of a fraction is okay, by the way. Having 0 in the denominator is bad. And if this might be a good time to kind of talk about that. If I think about doing 0 divided by -8, do like long division on this thing, think about how long division works. Usually what you're looking for is how many times does -8 go into 0, or 0 go into -8 rather. And so if I put 0 up here, 0 times -8 is 0, and then I subtract, and of course there's no difference there. So this is the answer. If I try to do it the other way, if I evaluate -8 over 0, okay, this is when we split the universe in half and all kinds of awful things happen, because this can't happen. If I try to do the opposite thing here, what times 0, what number can I put up here so that 0 times something is -8. Well, that can't happen because 0 times anything is always 0. So this one doesn't even make sense, right? This one is undefined, all right? But you can, just to get back to what we started with originally here, you can actually have 0 on the top and divide by another number, and that's always equal to 0. Anyways, okay, so that, of course, if I look at this graphically real quick, what's the slope of this line? Let's think about what that actually means. If I were to graph these points, 3, -9 would be down here somewhere, and -5, -9 would be over here. And of course, what that gives us is a horizontal line. That will always be true. Any horizontal line would always give you a slope of 0 because there is no rise at all. This number is always going to be 0 because it doesn't rise at all from point to point. Okay, so you're always going to have a slope of a horizontal line is always going to be 0. Which leads us to see what is the slope of a vertical line. So a vertical line, of course, is going to look the other way. And of course, this would be, many of you may remember this as just being undefined. But again, we want to think about why that is. So if you think about something like this, and you can just make a couple coordinate points up, it doesn't really matter. Something like 2, 3, maybe -4, 3, something like that. And you try to find the slope between those. All kinds of problems here. Because when I do my slope formula, I'm going to get, what am I going to get here? Oh my gosh, I did that backwards. I did that backwards. That one's wrong. Idiot. Alright, so this one is actually going to be 2, -4. What am I doing? Okay. Anyways, so what's that going to be? Here. And 2 minus 2. So that's going to give us -7/0. And this is where we get into undefined because, again, this value in the denominator here, of course, is a problem. You can't have 0 in the denominator. And so that is always going to happen because there's no difference in the x-coordinates, right? That the difference of the x-coordinates would always be 0 if I'm talking about a horizontal line. So vertical line is always undefined for that reason, I guess. Okay, we're going to skip on down to the next slide then and take a look at the last two. So what is the equation of a line that passes through the points -4, 1, and 2, -3? Okay, so there are a couple different approaches to this, and notice that this one is, we're trying to find the equation of a line. And so it's a little bit different than just finding the slope, although if you think about the things that you actually need to find an equation of the line, this one doesn't really specify what type of form we want that equation to be in. So let's just put it in point-slope form. And then we'll talk a little bit about how to make that conversion from point-slope into nx plus b or slope-intercept form. So, whenever you need the equation of a line, regardless of the type of equation or the form that you're putting in it, you definitely need to know what the slope is. So the first thing here would be to find the difference of the y's divided by the difference of the x's. And again, be careful with the signs here. It's really easy to make a mistake with that. And so what we end up here is with a slope of -4 over +6, which reduces to -2/3. All right. And so the easiest thing to do is to really put this into point-slope form. This is the slope of our equation. And remember that our point-slope form is essentially y minus, and it doesn't matter which one of these we use. Let's try -4, 1. We could do y minus this value here, which is 1, is equal to the slope times x minus the value of the actual point that you're given. Remember that x and y stay as x and y, but we want to plug in one of those points into this guy. And so that's going to be the opposite. It's going to be x minus -4, which is actually x plus 4. Okay, so this would be one version of the line. The other one that you could do is you could actually use this one instead. We could do y minus the y coordinate here, which is -3. So y minus a -3 is +3. Slope is the same, and then we get x minus 2 here. course, you may look at those and say, well, gosh, those are different. How can the same line have different equations? And the answer to that is just because that's the way that it is, because I can really put any point into that. All right. So you may want to put this off to the side somewhere. I'm going to kind of go down below here because I can, and I don't really have any other space. So what I would do with this is just show that if I do y minus 1 and actually distribute the negative 2/3 here, so I'm going to take this and just distribute it out. So get rid of the parentheses, not leave them in there. So that would be negative 2/3 x minus 8/3 when I distribute the negative 2/3 to the positive 4. And then this is going to give me, if I add 1 to both sides, I'm going to end up with y is equal to negative 2/3 x minus 8 minus 5/3, right? Okay, so that would be that way. And if I do this one, same kind of deal with the other one, but go ahead and distribute that negative 2/3 there. Okay, and then I'm going to subtract 3 from both sides here. So I'm going to get y is equal to negative 2/3 x. And if I add these together, or rather subtract, that's going to be 9 over 3. And that's going to give me negative 5/3. Ta-da! So notice here that these are exactly the same thing, right? They're the exact same equation, because now I've reduced it down to thinking specifically about, well, what is the y-intercept? And the y-intercept is unique for a line, okay? If negative 5/3, that's where the thing crosses the y-axis. Now I can't necessarily see that here in the initial thing here, because I have the slope, and that certainly stays the same from line to line as it does down here. But these are different because they're different points, right? So this equation may look different, but when I reduce it, or if I put it in slope-intercept form, I'm going to get the exact same thing, because it's still the same relationship between the variables x and y. And that doesn't change depending on, it doesn't change regardless of whether I'm looking at one point or another point on the line. It's still the same relationship. Okay, so we'll talk about E. Alright, so E, graph each equation on the axis provided. These did not show up real well, bummer. But you ought to be able to kind of see these on yours a little bit better. I might just kind of sketch this in real quick. So here I have negative 1/4 plus 6. And so this is, you're given something in slope-intercept form, you always start with a point. And that's actually true regardless of which of the two forms of the equation you're actually graphing. Start with a point. In this case, we know that this has a y-intercept of positive 6. And so I know that that's got a intercept right there. Okay, so the y-intercept of 0, 6. And then if I think about the slope of this, again, this is the rise, this is the run. Doesn't matter where you put that negative, but only use it either in the numerator or the denominator. So rising negative 1 means I'm actually falling 1 down to here, and then I go over 1, 2, 3, 4 units this way. So down 1 over 4. Down 1 over 4. Okay, or I can think about it as, positive 1, negative 4. So I can go up 1 in a positive direction, then negative 4 in this direction. Up 1, negative 4. Either way, I get negative 1/4. And my line then ends up, of course, looking like this, connecting all those points. So that's the first one. Second one, pretty similar, other than the fact that it's a totally different form of the equation, right? But I can still kind of do the same things for this guy. Namely that, this actually gives us a coordinate point on the graph. And the one thing to be careful of, and maybe I didn't make mention of this up here, but that these, maybe it would be a different page. What do I want to see? Yeah, okay, this guy right here. So these are always the opposite sign because of the negative sign that's here and here. the actual value of x1, y1 down here is going to be the opposite of what you see in the equation, because the negative is kind of built into the equation from solving for that slope formula. And so the idea with this then would be that whatever I see here is going to be the opposite. And so my x-coordinate, this point together, is essentially going to be the coordinate point -3 and +5. Opposite of +3, the opposite of -5. And so what that does is it gives me, one coordinate point on that graph. So over 3 up 5, there's the point -3, 5. And that's really the same thing as what I did for the first one over here to the left. That, just at that point was a little bit easier to find because it was always on the y-axis here. But this one, of course, is different. It's just that one point. But then from there, I can go over 2 and up 5. Sorry, I did that backwards. I can go over, I got too many circles here. Slope is 2/5, which is the rise over the run. So I can go up 2 and over 5. 3, 4, 5. That gives me another point. 1, 2, 1, 2, 3, 4, 5. And I hope these come out a little bit more pretty on yours, because you actually have a graph. I'm kind of making it up. But then I can also do -2, -5, because the value of that is positive. So I can go down 2 and over 5. Down 2 and over 5. Okay, so if you have actually graph paper, it comes out a little bit cleaner. But essentially what we want to do then is, of course, just connect those points like that and get that. And notice that when we have that line, that the positive slope here does, the line is rising from left to right because I have a slope of a positive 2/5, and over here with the first one, the slope is negative, and so you can see that it's falling from left to right. Okay, so that's all that I have. So yeah, I guess you have 2 options here. You can start in on the homework, or just kind of get ready for tomorrow's quiz. And I think the sub maybe would have already told you that, but this is it for section 3.7.